Okay, let's go ahead and get started. Hello, everyone, and welcome to today's webinar on generative AI solutions for real-world problems. My name is Josh Elliott, and I'm one of the co-founders of a software solution called Modzy. And at Modzy, we partner with companies to make it easy for developers to deploy, run, and monitor production AI at scale, both across enterprise and edge applications. And our webinar topic today is certainly applicable. I'm joined today by three other amazing technologists and AI practitioners. Let me start with my colleague, Brad Monday. In addition to being an all-around great guy and applied mathematics expert, Brad is Modzy's head of machine learning engineering. Brad has extensive experience in the data science trenches, building a variety of machine learning solutions for both commercial and public sector organizations, as well as assisting them with their AI adoption journeys. At Modzy, he leads all things machine learning engineering and is an influential open source contributor and works closely with our customers to help them integrate Modzy into their data science and MLOps tech stacks. Also joining us is Scott Cohen. Scott is the co-founder and CEO of Jaxon.AI, an AI training workbench and prototyping platform for building custom AI applications. Scott is a career technology entrepreneur and patented inventor with a focus on movement and manipulation of data. Prior to Jaxon, Scott was the founder and managing partner of Big R.io, a machine learning consultancy that helped grow to an exit in 2019. He's worked with companies like Amazon and eBay to help seed the initial idea behind Jaxon. And to round us out, we've also got Greg Harmon, also a Jaxon co-founder, but their CTO as well. Greg has an extensive background in enterprise data architecture, applications, and automation. Prior to founding Jaxon, he spent over 15 years in the CTO and architect roles, developing technology strategies and platforms to drive business growth. His past work has been utilized by millions of end users in organizations ranging from the Fortune 100 companies to the Department of Defense. So before we get into today's topic, there are a couple of housekeeping items that I'd like to cover. First, I wanted to let you know that there will be a recorded version of this webinar made available for download in the next couple of days. Please keep an eye out for an email with a link to the recording. Secondly, we'd love to hear from you, both during today's presentation and after. If you do have a question during today's talk, please post it in the Zoom chat channel, and we'll do our best to address it either during the webinar or at the end or after. And for those of you joining us just now, my name again is Josh Elliott, and I welcome you to Modzy's webinar on generative AI solutions for real-world problems. In today's session, we're going to provide a high-level overview of what generative AI is and why it's so hot today. We'll cover some of the applications and challenges associated with it, and then we'll also dive into practical applications of how generative AI can support contact center operations specifically, using both Jaxon and Modzy software platforms. So let's jump right in. Brad, could you go to the next slide, please? So if my social feeds are any indication, the last few weeks have really certainly featured some pretty interesting things and updates in the world of generative AI. Most interesting, as a release a week ago, came from OpenAI with an announcement of ChatGPT-3, which is part of the initiatives around GPT 3.5 model. ChatGPT is a language model optimized for dialogue, which means that it can follow the context of a conversation at a very deep level and answer follow-up questions and even admit its mistakes. Google also released String Fusion, a text-to-3D model that can produce incredibly realistic results. And then generative AI was also a big focus of our past NeurIPS conference, including NVIDIA publishing Get3D, another generative 3D model that can produce complex textured 3D meshes, and MindClip, a foundational model that was pre-trained with YouTube Minecraft videos and then used to train a reinforcement learning agent able to complete several tasks on Minecraft. So why now? Well, clearly there's a lot of great fundamental research that's significantly increasing the performance of models. We also know that computing horsepower to train those models has increased significantly over the last decade. And clearly there's way more data today than ever before, which is used to fine-train and fine-tune those models. For the last decade or so, we've seen AI applications focus on making recommendations or predictions. What generative AI is doing is really laying the foundation for AI to move into new applications that are both prescriptive and or proactive. The important thing to note is that because the research and significant progress is being made in transformer models, which, by the way, are models that can infer context and meaning by tracking relationships in sequential data, we are now able to do what was not possible. So let's go back and describe what generative AI is. Brad, could you go to the next slide? Generative AI refers to unsupervised and semi-supervised machine learning algorithms. And this really enables computers to use existing content like text, audio, and video files, images, and even code to create new possible content. The main idea behind generative AI is to generate something completely original so that it appeared to be real. Brad, next slide. To show a concrete example, this morning we actually used OpenAI's ChatGPT tool to see what kind of answer it provided to the question that we just posed. If you take a look at it, it's actually not a bad answer at all. And what's really cool about what OpenAI's fun tool is doing is that it not only reduces the friction for using the underlying AI models, but it's a great warm introduction to the future of AI. One that is not just about making recommendations, but one that has massive potential to change the way companies operate and humans live. Scott, just a quick question for you. What is it about generative AI or the generative tech sector that excites you?
Thanks, Josh. Hello, everyone. Yeah, I think ChatGPT is super cool. I've been using it a lot. It's impressive in its responses. Writing prose is going to be helpful for a lot of content writers. I don't think it's going to replace people per se. I think it's going to be an assistant that will expedite a lot of their jobs. I think the imaging stuff is really cool too. You'll see it later on in the presentation here. I used it to create some images. That's fun. I can see some real world applications in that for things like prototyping new ideas and putting it from words into images. But I'm particularly biased in this space as to where I think generative AI has the most applications. And I think that's for enterprises looking for real world problems to be solved and using generative AI to create synthetic training data to train those transformer models that you were talking about before to handle company-specific, domain-specific use cases.
I appreciate that, Scott. Thank you very much for that. Brad, if you could take us to the next slide, we'll start talking a little bit more about the research and practical business applications. So most of the applications of generative AI are considered very narrow prototypes today. And even some in the industry refer to them as one and done types of tools. So if you think about that, you're putting an input in, and in our case, the question, what is generative AI? And you get an output. Now, the research is absolutely great. And like I said, these recent tools are a great warm introduction into how humans and machines are going to collaborate. But it's more than just some fun tools. There's actually significant opportunity for generative AI to create massive efficiencies for both knowledge and creative work bases. Brad, if you could go to the next slide. This new form of generative AI is going to impact a wide range of industries and business functions. And I really like this chart produced by Sequoia. It shows different use cases that span a wide variety of data types generated, such as text, code, images, speech, video, and gaming, for instance. And at every turn, there's going to be opportunities for generative AI to create and proactively take action on all the hidden data and insights that exist around us. More commonly, we're seeing generative AI take form in marketing applications. If you look at Jasper, for example, it's a marketing-focused version of GPT-3, and it can produce blogs and social media posts, web copy, sales emails, ads, and other types of consumer-facing content. And most customers are also small businesses today, so PR and social media agencies are going to really take and see efficiencies from this technology. Other areas like code generation are also pretty strong. Large language models and code generation are good for snippets, but integration into the broader context requires still human input. And then you're seeing a lot of conversational applications. Again, those large language models underpin the core conversational AI and the chatbots that you see today. This is allowing businesses new ways to reach and engage with the customers and greater awareness and conversational understanding than the current conversational approach or tech. I'll just reference a couple Gartner stats, but by 2025, 10% of all data produced, they anticipate will be created by generative AI. They also think that data augmentation is a great use case and application for AI today. And we'll see an example of that specifically around artificially augmenting a data set with data not previously seen to improve the performance of a model. And in that vein, Gartner also predicts that synthetic data will increasingly be used as supplement for AI and machine learning training purposes. And the research giant projects that by 2024, synthetic data will be used to accelerate 60% of AI projects. Pretty significant. So on that note, I'd love to turn things over to Scott to talk about all the amazing possibilities. And let me hand those reins over to Scott, and he can share some of the thoughts and challenges related to generative AI.
No, thank you, Josh. Interesting stats there. I hadn't heard both of those, but I believe it. I think that the training data divide is still very present, and these newer techniques can help alleviate a lot of the pains around data prep. And most people have seen this stat: 80% of creating AI is data prep, and that's very true. And oftentimes the data itself is lacking. When you're trying to train these models to cover all the edge cases, there are gaps, and it's not representative for all those edge cases. So you can fill in those gaps with the synthetic data, which I think is partially why people are so excited about it. The other thing are these transformer models have voracious appetites for training data. The more you can give it, the better. So it really is a way of expediting the whole process of getting these models trained. And I'll get into this a little bit later as well. Once they're trained and in production, you want to retrain them. And it's a constant loop of training and retraining to keep those models accurate. Next slide, please. So some of the challenges here, because you're using real data. Even ChatGPT has combed the web and read a whole bunch of books on various subjects to be able to regurgitate what it does. Is it enough though? And it depends. The canonical engineering answer is it depends on the use case, but that certainly is a real challenge. Does it represent a real world problem that is company and domain specific, like I was saying before? If it's a cute question answer like everyone's playing with ChatGPT, it might work pretty well. But when you get into some of the use cases that we run up against, you have to temper it, if you will, and make sure you still keep humans in the loop to ensure the accuracy and the proper coverage of the data. Privacy certainly is a concern. I just saw something this morning where there's some regenerated artworks, authentic AI artworks, but they have the signature of the original painter still on the image. So there's a lot of borrowing of original content here. And then the bias comes in where, just like humans, data can present bias. If all the data is representing the world in a certain way, the models are going to be trained in that way. So again, you want to temper it so that it is properly balanced.
Hey Scott, if I could interject real quickly, we got a question sent directly to me from the audience. So what are some of the risks that we need to pay attention to with respect to generative AI, both in development and in production? Can you weigh in on your thoughts there?
Sure, yeah, I was starting to allude to it, but these generative AI models produce a lot of, let's just say, not perfect examples. And you want to be able to make sure that those not perfect examples don't make it into a training pipeline and impact the learning of the models. So curating the synthetic data, I think, is a big piece toward alleviating some of those concerns.
Excellent, thank you.
Yeah, absolutely. I think I was done with this slide. Oh, I just want to point out that those images that you saw there were actually generated by generative AI. I thought those were pretty cool. I just put in the keyword realism, and that's what it spit out. All right, next slide. So our take on this is to use real data. We also generate completely fabricated data, just like GPT-3 does. But for the most part, we're trying to tie this to a real world problem. And so we're using representative data from our customer. A customer loads in their data, and then it goes to this pipeline to create augmentations. That's what we call it, augmentations of the data, where it changes it slightly. It might swap a synonym. It might swap a word in that it sees in the same data set, but it uses it for that specific example to do a swap. It also can do words that are seen frequently within a corpus of text to, again, augment the examples. With Jaxon, we're multimodal. We are very much focused on natural language processing use cases, but we're finding that a lot of them have tabular data as well. A good example is a tweet. We'll have the content of the tweet, and you want to understand the content, but you also want to understand the metadata about the tweet, how many likes, how many followers, to rank its importance. So we marry tabular data in alongside the natural language. And for the tabular data, we're doing similar approaches, very much statistical based approaches to augmenting this data and getting an inflated training set on the other side. And Greg will get into this, I think, a little bit later. And what I said earlier is still true. It may not be perfect. I'm being delicate about that subject. So you want to try it and see if it does in fact impact the model's training. And that's how you can, turn the knobs within the platform to get it just right. And so it's a very much iterative process. Next slide, please. So with Jaxon, we take the raw data on the left side. It comes through a pipeline where you're designing your models, you're articulating the specification that you want to have the models adhere to. You're prepping the data, which might mean the synthetic data generation. It might be some labeling on the real data. It might be some what's called pseudo labeling on the real data, which is an auto labeling step that's going to use these models to label the data. And then it can do a round trip within Jaxon where you're using that pseudo labeled data to retrain those same models and keep improving the accuracy of the models. And that's where the modeling and evaluation comes in. When the model is trained and ready, it then goes out of Jaxon. It gets downloaded as a Docker container, and that container goes over to Modzy for production. Some of the issues with production, next slide, please, Brad. Some of the issues is you have a model in production, you want to keep track of it, make sure that it's not experiencing things like data shift, because the real world changes constantly. If we're talking about natural language, the vernacular and the way that people are talking about things are constantly changing. This is somewhat of an old spiel. When I get into this, you'll know why. Where the word mask 2 years ago drastically changed from the year before, and how people are using the word mask in conversations has changed. So you want to adjust these models to recognize those changes. It's funny with ChatGPT, you can see that it was trained with data from 2021 and prior, and it doesn't have any current knowledge, like this year's knowledge. The other issues with models is, covariate drift and related to the data shift that I was just describing, that it needs to be adjusted. It needs to come back for training. And that's the feedback loop I was alluding to before, where once the models are trained and in production, they can, with an API call, come back to Jaxon to retrain. And that's a continuous loop. Brad?
Awesome. Yeah, thanks so much, Scott. So now what we're going to do, we're going to shift to an actual demonstration that leverages both Jaxon and Modzy to solve a real world problem in contact center operations. So before I hand it over to Greg, I wanted to just set the stage quickly for what the demo will include. So when we think about contact center operations. There's tons of data that the operators and agents deal with on a day-to-day basis: audio data, text data, data from both direct and indirect customer, feedback interactions, and all this data really makes contact centers a ripe area for AI. Things like speech transcription, human-in-the-loop learning, voice of the customer, NLP, and even generative AI. So what we're going to show today is a fusion between the Jaxon and Modzy platform to enable a end-to-end holistic solution, starting with data science and pipelining with Jaxon. And Greg will show you how we'll take an open source data set for the purpose of this demo, leverage Jaxon's platform to for the synthetic data labeling and model training component. We'll then export that model into Modzy, where at Modzy, from a platform level, we'll serve those models through scalable APIs, which really enable a whole plethora of integrations. And what we're going to show today is an integration with Qlik that can build custom AI-powered dashboards directly and deliver those to the hands of the agents and the operators. And then finally, very importantly, when we're talking about generative AI in some of these use cases, is that monitoring component. So what we'll be able to do is take predictions that are stored within Modzy, map those to the production data, and import back into Jaxon. So that's the general high-level flow. We'll reference this architecture a couple times throughout. So with that, I will pass it over to Greg to kick off the demo.
All right, thanks, Brad. All right, so I'm going to take you guys through a little bit of how the sausage is made in terms of creating a model that you might want to deploy to Modzy. And one of the keys here is that we're trying to make these models very easy to create and then to update and improve. And there are an awful lot of different tools in the Swiss Army knife, as it were, of tooling here, but I'm going to take a particular focus on the bits of this that involve synthetic data and generative approaches, just to try to keep this contained to a few minutes. So we mentioned that we're doing a customer support application, and more specifically, what we've done is actually scraped up a bunch of public tweets sent to McDonald's, and we're trying to categorize these and try to figure out which ones fall into different categories. And in particular, we're going to be worried about the issue, people reporting legitimate issues rather than, as we go through this, you'll find in the data that there's an awful lot of people shouting out their favorite food and that sort of thing, or bring back the McRib, bring back Szechuan sauce and all that good stuff. So that said, let's see what we can do with some tweets that we scraped up. So before we get into the models, I want to just show briefly that there are an awful lot of copies of what look like data sets. There are probably a couple of dozen data sets here. All of these are different derivations of the original scraped data. Certainly, we do things initially like splitting off, a training and validation set. But when we get into the business of synthesizing new examples and synthesizing new labels and data sets, we want to keep all of these separate so that we can track some lineage and history and keep everything clean. So I just want you to see how much variety that there ends up being, all derived from a single original source data set, in terms of different ways that we can train. And we'll dig into the the gory details of some of these in just a moment. So first, let's take a look at just a clean, original, unaugmented data set. And so here's a simple example. Clear this out from an earlier go around. I'll show you how this works in just a moment. We have a raw tweet here. I just want McDonald's in the nap right now, so on. And I can pick, from, amongst the different examples that we have here. I can, take a look, and here are all the different classes that we might want to label. So I can do this by hand, but there are a whole lot of options that I have in terms of how might I project. So right now I'm talking about using, either humans or a combination of humans with generative prompts to come up with, different potential labels that I might want for this particular example. So when we think about using generative AI for the specific use case of preparing training data, there are two sides to it. We have the X's and the Y's, if you will. The X's being the original data or the features derived from the data, and the Y being our labeled annotations. And there's value to synthesizing either side of it, depending largely on the nature of your data. If you have a big pile of data, usually the assumption is that data is cheap, but it's expensive to get annotated labels. You need humans in that. Then you get into the business of needing to synthesize pseudo labels or weak labels, or a lot of different ways that we can get into doing that. But on the example side, sometimes you either just don't have examples, they're expensive to get, or you have them, but there's such heavy skew that it's really difficult to get examples for some of the sparser areas of the data set, which inevitably are the ones that you're really looking for when you're trying to sift needles out of haystacks. It's a really common pattern. So you get into different types of generative AI, and one of the themes I'll come back to is that, and I'll show you some actual synthesized data in just a moment, is that accuracy is not always what you're after, but rather usefulness. I like I have a couple of mantras I live by in my machine learning world. One of them is that data and models are not separable. Models are, you can think of as just views on a data set. And then the other thing I like is the old saw about models, good old George Box. All models are wrong, some of them are useful. So apply those things and it brings you back to data. All data is wrong, but some of it's useful. We worry so much about where are the errors in synthetic data, and we forget that the data itself and the human annotations are also error laden. And that's okay. We just need to make something useful as defined by how predictive our model is on the actual data that we want it to predict. And we'll come back to that as well. So you can see that this example I pulled up has a proposed label of suggestions, and I can go with that. A lot of different means of creating things. I can also pull up an unlabeled example. I can ask for a new suggestion on this. So what we're actually doing now is we're actually going back and asking a generative AI of some sort. In this case, we just have a little BART model, which for those who aren't familiar is pretty similar in spirit to the GPT-3 and the big language models, but small and self-contained, and this can fit on a single desktop. There are of course trade-offs in terms of the accuracy and the capability, which brings us back to, is it useful? Do you need all the heft of the GPT-3 in order to augment your data in a useful way? Sometimes, but not necessarily. So just before I move on to more of the model building, I'm going to show an example of, let's pick a good one here, of what some augmented training might look like. So this example is a completely synthetic one. It would be based on an original real example just to get the theme and the style and even some of the content. But some of this is synthetically generated. And then there are a lot of ways you can do it. You can go to things like the big language models and the big image models and the things that have captured our attention. But if you're paying close attention and reading the fine print on some of the slides, there are also really simple techniques, like doing things as simple as swapping words around and substituting synonyms. And what's interesting is that the seemingly simple things that you wouldn't even think of as being quote unquote AI, when you start combining them in clever ways together, you can get some really interesting emergent properties to them, and it all mixes up and causes the same effect. So deep learning and transformers are awesome, and they're changing the world, but they are not, never have been the only way to get there, and ultimately we're after effect. So it's a good mix of the new and the old, the complex and the simple, and what we're really looking for is effect. Just one more example of a way that we can use generative AI to create labels quickly. I'm showing you another means that we have here where I can create a zero-shot classifier that's not the thing we're trying to train here. So instead of worrying about the different themes in our food. Is this a chicken sandwich? Is this an issue being reported? Is this a general rave? I can create, this time I'm just going to separate out. I'm going to say morning, noon, and night. That's my 0-shot classification. If it's morning, I'm going to label this as breakfast. And if it's noon or night, it must be something else. And I can even test out a couple of things. I can say, hash brown, and nobody let me do something that's cheating here, like putting the words in the morning, but hash browns first thing. What will we get? Will we get breakfast? We do. It's figured out that that's more associated with morning than noon or night. And notice that I haven't pre-trained any models here. This is just using this is the same BART model just being crafted to a custom 0-shot learner. Let's try something else. Burgers for dinner. And we get an abstention, which in this case is our way of saying it wasn't breakfast, it was something else, since I'm really just trying to identify breakfast versus not breakfast. So, one more angle of how to take, the generative options. Technically, we're first generating this quick classification model, and then we're using that to generate a decision on a particular positive or negative pseudo label here, and that's a great way to kind of bring this thing down as not the end product, but rather a tool in a greater chain. So cutting to the chase now, we're going to take a look at actually creating models. And so here's a list of different models that we're able to generate with the system using different combinations of exploring the parameter space, as well as some of those different data set options that I showed you earlier. And just very quickly, I'll show you, here's a very first naive approach. And we get an okay Distilbert model. This one is intentionally a baseline, nothing fancy here. This is just our original human annotated small set. And it's pretty good at some classes, lacking in some others. And in particular, the issues class is the one that we're most worried about. So we can see it's not so great at that and a couple of others. And we want to look to how can we improve that. So we can do a couple of things. So for example, here, we've taken the exact same model architecture, so still Distilbert. We're starting from almost the same data set, but what we've done is we've added in some of those emergent augmentation I mentioned. So this used only the simple ones, but it did some clever things during training to be able to capture some of those emergent behaviors, doing this on the fly in this particular case. And you can see that we're able to actually get quite a boost in terms of overall F-score. And we've improved our 3 really troublesome classes, at least somewhat, which is what we're most interested in. And we can, however, do even better. So one more I'll show you here is we can, and full disclosure, this one has happened to jump up from Distilbert to Roberta, so we are using a little bit bigger model, a few more parameters. But notice that these two that I'm highlighting, and I'll zoom in on one, are now using not just what we did before, but also some of the augmented data vis-a-vis the actual full-on data set synthesis action. So in this case, we've doubled the size of the data set, half synthetic data, half real. In this winner, where we're up to 80% now, we actually have 2 times the augmented data as the original data. And as you can see, things are looking quite a bit better, even amongst our classes of concern. So I'm going to stop the demo there. I could keep going on this stuff for a couple of hours, but I think I would lose the audience. So I'm going to turn it back over to you at this point, Brad.
Thanks, Greg. Let me share my screen again. Awesome. So what Greg just left off with was, the result of leveraging some of Jaxon's tools for data augmentation, synthetic data generation to ultimately train the highest performing model. So, at the top of Greg's screen, you saw an export button. So all you need to do is export that model from Jaxon. It comes out as a container, and through in this integration we've built, you can deploy that directly into Modzy. So before I jump into my side of the demo, I wanted to just again, set the stage of where we are. So we just went through this first box. We're going to take the model trained on McDonald's tweets. for customer support use cases, voice of the customer, et cetera, deploy that directly into Modzy. Now in Modzy, it will be stored in our private model library. We can do custom things like A/B testing, because again, now we're transitioning from training and pipelining from a data science standpoint to a production standpoint, an operational standpoint. So, we can make sure that we are deploying the best models into our end application. Through our APIs, we'll be able to build that integration directly to Qlik. So without further ado, let me share my other screen and walk you through the Modzy and Qlik components of this kind of end-to-end solution. So as I mentioned, first step, we take that model, built and exported from Jaxon and deploy it directly into Modzy. So we support models built from all different frameworks, all different tools, platforms, Jaxon being one of them. And through the automated integration we built, we suddenly have this Jaxon model in our central private model library. Now, a couple benefits here. When we talk about ML ops and operations, governance is a really big deal. Management, versioning, and transferability and shareability. So we've got all of our models. If I were to go filter by models developed by Jaxon, we see this issue detector model right here. And at this point, what we see in this model card, this details page, through custom documentation, we have all the information, all the details that an end user would need to understand when implementing this into some front-end application or use case. So again, let's go back to the contact center operations use case. And so let's say that we're a data science team supporting that team, right? And our task is to build some sort of dashboard or front-end tool that enables them to take advantage and be able to access and consume and digest the results of these AI models. So, off the bat, we see, what does this model do? It's great for voice of the customer. We have some high-level analytics data, some performance metrics, some of these metrics that we can pull directly from Jaxon. In the transparency and bias section, I gain a better understanding of how this model was built, any underlying architectures used, links to data sets, et cetera. Again, in this example, we're using an open source data set. But I think most importantly, where I want to spend the most time is this API section. So again, with Modzy, everything that you see in the demo is completely API based, which opens the door to a whole collection of integrations from database tools, model training tools like Jaxon, and most importantly, front-end business app tools. In other words, a way to build solutions that give non-technical folks an easy way to digest and consume AI. So with a couple lines of code, it's a standard, consistent API for every model. Every model has a unique identifier and a version, and what we can do is build, some custom application. In this case, we've built, oops, sorry about that. Let me refresh this. Joys of a live demo. There we go. So what we built is this custom Qlik dashboard, right? Natively and traditionally, Qlik, just like Tableau and other dashboarding tools, provides easy, data manipulation, transformation, and prescriptive analytics. In this Qlik dashboard that we've built, we've now added an AI and predictive component. So a couple things I'd like to point out here. The first is that we've built a data connection, a custom data connection directly to Twitter. And so what we'll do is we'll download about 1,000 to 1,500 tweets with the search query parameter as the @McDonald's handle. And then what we'll do is through a custom REST API connector that we've built, we'll take that data through Modzy's API, send all this to that issue detector model, and then we'll extract the results back from Modzy. So that sending data to and receiving inference results back connection all comes from Modzy's APIs. And so, out of the box, some of the prescriptive charts we can build, word clouds, specific correlation charts. In this case, what we can do is actually summarize and synthesize the predictions that our model made on this fresh data dump directly from Twitter, and see the different categories, the category breakdown for the particular model and set up data. So this is great in and of itself. Again, we've kind of added a predictive component to this dashboard that any operator, any analyst, any agent can use, out of the box. Let's take this one step further. I talked about this model library that you have available. So you could have models that your team has built in-house, models that you've built with the Jaxon platform or other training tools all in one central place, and you can access and consume those models with the same API. So in this sheet, what we're doing is we're building a comparison to another model from our Modzy library, and this one being a sentiment analysis model. And now we can do all sorts of fun things like build comparisons between average top confidence score, of the 1,500 tweets that we've downloaded. We can compare latency breakdowns. There's different performance metrics that Modzy captures through the inference cycle. And I think more importantly, what we can do is build this comparison chart or heat map, where we see on the x-axis the sentiment classes that were predicted, and on the y-axis the issue detector, that again coming from the model that Greg just showed us that we trained. And from here, there's all sorts of actionable insights that give operators, agents an easy ability to take action, right? The highest weight here we see in our heat map is this tweets classified as joy from a sentiment standpoint and general from an issue detector, right? But things that we might be interested in are potentially menu items or issues in here that have either a very highly positive or negative sentiment based on this model. So again, a way to kind of combine the collection of a couple models and inference results from a couple models to make your analysis stronger, more robust, more comprehensive, all with a simple click, right? And an operator can simply refresh data and have these insights in front of them, instantaneously. So, this is, one component of this. Through Modzy's APIs, we've built this very customized dashboard. But when we talk about generative AI techniques, and any AI for that matter, what's really important from an MLOps standpoint is monitoring. So with Modzy, there's a couple features that I'll highlight as it pertains to monitoring. The first is drift detection. Scott talked a little bit about the importance in data drift and covariance drift and all these statistical measures that you need to compute to make sure that your models maintain the performance that is expected as the outcome of training, right? And just inherently that will change over time as the production data that the model sees will likely change. So, automatically Modzy will compute drift scores using the chi-square statistical test. And what we can see here is drift scores over time, in addition to more detailed changes of output classes and distributions. And then finally, how frequently does our drift fall under certain thresholds that we set and that we can customize completely in this configuration tab. So this is one component. Again, let's go back to the data science example supporting the contact center operations team. As you're monitoring the results over time for your model, right? In this case, there seems to be some sort of spike in drift. And if you wanted to take a deeper look, one step further, what we can do is look at explainability. Now, explainability, there's lots of algorithms out there, some common open source ones, OneBeat, Lime, and Chap. And it's a lever that you can optionally implement in your model container in Modzy. So in this case, we're working with a Lime explainer to help us understand why the model is making the predictions that it's making. And you can see, different visualizations on our dashboard here, including highlighted words. You can, toggle between different classes that we're explaining, in addition to some of the word scores here. But most importantly about this feature is, again, let's take the example where your model may spike, or model drift may spike, or it's consistently high. And as we're going into our explainability tab, we're noticing that the models are making the correct predictions for incorrect reasons or incorrect predictions for incorrect reasons, right? So what we have here is this mechanism for human in the loop feedback, which is critical when you're thinking about the full cycle of MLOps and human in the loop learning and feedback mechanisms. So let's say, for example, that I were to select this as correct. Chicken sandwiches at McDonald's are the most disgusting thing I've ever eaten. That is an issue, but it was correctly predicted. What I can then do is click on this job ID. And what we see here is the result for this particular inference job. The raw results right here. And more specifically, we can see the vote that I just cast as this is correct. Well, as my other data science teams kind of continue to provide feedback on inference results based on explainability and drift detection, we'll accumulate those votes in the results object. And so then if I go back to all my inference jobs, we have this full audit trail in every inference made by every model, by every user, and there's all sorts of filters. Well, what's important to us is to be able to select the inferences that we can map to a specific set of production data that were perhaps incorrect predictions. And what we can do is export these directly to Jaxon, so that we can then kind of feed that loop back, right? So let me just go back to my slide here real quick. And what I'm referencing are these boxes that are, or these arrows rather, that are taking data, production data in those raw predictions as labels and going back to Jaxon. Because what you can then do is kind of go through that same process that Greg showed us. As data scientists, you can maybe tweak some different levers in both the labeling and training pipelines, right? To, with your production data, build a higher and more performant model that we can then deploy back to Modzy and continue that cycle. So again, both Greg and I covered some of the features at a very high level, some minimal features. In this case, we worked with Qlik for contact centers. We can make that integration directly to ServiceNow, to Five9, to TalkCloud. The app itself and the use case itself and the data, it can all be interchanged to build a very bespoke and custom application based on use case. And so just to conclude the demo, a couple of takeaways that we'd like to highlight here. And the first is that synthetic data generation really enables more effective data set augmentation and really cuts down the data science prep. It's the idea that Scott and Greg talked about, that data scientists should be involved in the design of the pipeline, not the pipeline itself, right? The second is that solutions like Jaxon and Modzy make generative AI models and models built using generative AI techniques, right? Accessible beyond just research-based applications. We saw that today, through our kind of automatic integration, where you take an exported model from Jaxon, import it to Modzy. You can build all sorts of custom integrations that give these solutions directly to the end operators, the end analysts, to consume in a software that they're used to working with. And then finally, you can't really have any sort of AI solution end-to-end holistically, whether it's generative AI or not, without model monitoring. So robust model monitoring and that human-in-the-loop feedback is really essential to making sure that your models are continuously maintaining that optimal performance. So with that, I'm going to pass it back over to Josh to facilitate the question and answer session.
Thank you very much, Brad. Great job, Greg and Brad, for giving us the walkthrough of that contact center operations. We did get a couple questions come in over the chat. The first one I think would be great for you, Scott, to take. It's from Seth Clark, but does using generative data for training help reduce overfitting? You have any thoughts on that, Scott?
I do, and I want to say yes, it helps address it, but I actually think Greg will give a more concrete answer. So I'm going to pass the buck on this one to Greg.
I agree. Yes, it will help reduce overfitting. That's really, reducing overfitting, or another term, generalization, is really the point of bringing in synthetic data when you have a small data set in particular. But any sort of augmentation, that's what you're trying to do. I think one of the keys, though, for making that work is that you take care to keep all that synthetic data in your training set and keep that out of your validation and test sets. Because if you bring them into the testing side, then you have this sort of self-fulfilling prophecy that doesn't actually move you forward. But if you're measuring how you're doing against real data only, and then you're bringing in synthetic data and tweaking out synthetic data to help drive your predictions on real data only north, then you're doing a good thing.
Thank you both, Scott and Greg. The next question that we have here is, and maybe Scott, this goes to some of the content that you were talking about earlier, but you talked about some of the challenges with realism, privacy, and bias that this type of generative AI can exacerbate. Do you have any recommendations or practical steps that companies can take to overcome these types of challenges?
Yeah, I'm working on that right now with the Department of Defense, where they don't want to let certain people see certain things, and things need to be redacted. So redacting is one way of doing it. Being in control of your data in general is best practices. Like I was alluding to before, there might be some plagiarism going on with some of the generative AI models that are in consumer-oriented settings. But when you're using these for real-world problems, control the data that's going in, and as you're picking and choosing the features for your model, make sure that those features line up to real-world problems. I was just talking to a potential customer the other day about the subject, and they tried it for replicating electronic medical records. And it could jostle up the data and produce a medical record, but it wasn't grounded in reality. There was a diagnosis code, as an example, that was garbled up in the synthetic data mix, and now it didn't align to the federal standards. So you have to be really careful about those kind of things. And that's where I believe some of the other pieces of the puzzle that we didn't get a chance to talk about today fit in, like using a knowledge graph to put up guardrails as to how to keep relationships between properties intact.
That's excellent. One thing that I would also add, and I think you saw elements of it in the demonstration that both Greg and Brad provided, was to really think about the process and how you automated both the training as well as the production, deployment, and monitoring type of capabilities to create that feedback loop and make sure that your models are constantly being monitored and your data science teams are alerted for when there's possible drift or non-performant aspects of your model, so those models can get retrained and new versions can immediately be pumped out. The other thing that I would add is, understanding and documenting information related to those models, whether it's details like the training data that was used, the type of model architecture, and any potential bias or other concerns regarding that data, making that available for end users to understand before they start using the model is also critically important. And then, like I said, in terms of the monitoring for drift and making it easy to understand and create that new training data set that gets sent back to your training tool, I think that's critically important as well.
Yeah, I think that's spot on. Yeah, one thing just to add to that, the data science really is science, and you need to keep track of your experiments. You need to know what you're working on to be able to translate it to those downstream that might be using it, or upstream.
Excellent. And then I think we have one final question for maybe Greg or you, Scott, or Brad, to take a stab at. This came in. Where do you think more research is needed to move us away from the fun applications to those that can really transform the businesses that we were talking about earlier? Scott, you want to take a first cut?
Yeah, I'll take a first crack, and then I'll pass it over to Greg or Brad. I think the research is there. We have what we need. It's now using those tools and tying them to real world use cases where the human in the loop really understands the use case well and can translate that into not just the data and the model, but the overall system of models that are going to solve a discrete problem. Greg or Brad?
Yeah, I'll agree with Scott. I think, in terms of theory, the theory is way ahead where most of the practice is. And it's really, any research we need is more around, applied research and, research into, clever ways to bring some of that theory into practice and solve, a real problem, going beyond demos that are fun but not useful to those that are boring but useful. And just as to add some specifics to, his claim, as we saw earlier, and just as anyone who's been following the space has seen in recent weeks, ChatGPT is the new shiny, and it's a fantastic tool. But if you dig into the theory, there's nothing new there. It's some clever training really over GPT-3, which itself was nothing but scale on top of GPT-2, which was a prototype of the sort of fundamental theory, from GPT-1. I mean, hence the sequential naming. And it's largely been a case of scale and sort of applied tuning more so than any really new theory or research fundamentals that have occurred.
Brad, do you have anything to add? If not, I've got something that I can add as well.
No, go ahead, Josh.
I was just going to say, with respect to this type of technology, generative AI is certainly going to increase the hyper personalization of the end user experience. And I think with the combination of this type of tech and 5G and being able to move, and IoT devices and being able to move inference, closer to where the data is captured. I think, more research is going to be needed around generative AI and actually making these very large models much smaller. So we kind of go through this small to large to small environment. And I think we're going to see that some more research, or need some more research to actually move us that way. The other thing I'll say, and I think this has to do with, a lot of the potential for deep fakes out there is making sure that we understand how to identify those and have the technologies and tools to actually understand and recognize when these things that are seemingly becoming more and more real could actually introduce risk into organizations' processes or end user situations or scenarios. So I think there's more opportunity for research in those areas as well as this technology improves. Brad, anything else to add? Awesome.
You guys covered it.
Well, folks, I think we're coming up to the end of our webinar today. I do truly thank you guys for spending an hour with us. Again, this information, this recording will be made available to you over email in the next day or so. Please be on the lookout. And if you'd like to continue the conversation with both Jaxon and Modzy, please feel free to reach out to us. Our information will be included in that email, and we'd be happy to help you think through or strategize how you apply generative AI to your businesses and organizations. With that, enjoy the rest of your day and the holiday season, and we'll be in touch.